welcome to Algebra 1. Today we are going to be adding and subtracting radicals. So let's just get to it. Let's start with the opener. The opener problem is asking for you to simplify the expression. So to simplify the expression, we want to go ahead and perform the operation of 5 multiplying the quantity of 1 plus 3x. So the 7x or the negative 7x, we do not touch that at first because we need to multiply 5 times 1, which is 5, and 5 times the 3x, which is 15x. So now we can combine like terms. So like terms are going to be these two right here because both of them have an x. And so we're going to combine those. It's negative 7 plus 15, so that's going to give us an 8x, and then we have that plus 5. And we cannot add those two because they are not like terms, so we have simplified that expression all that we can. Okay, so today when we are adding and subtracting variables, it's really important to be able to identify if the radical needs to be simplified or is there no longer simplification that we could do. So, is that a word, simplification? No, I don't think so. I think I just made that one up. Okay, moving on. Let's take a look at example number 1. Now there are 6 examples for today. So example number 1, I'd like you to go ahead and take a look at what we have. We have negative 3 times the square root of 18 plus 2 times the square root of 18. Now radicals, if they have the same number, radicand, in the square root, then you can add them. So both of these, we can add them. I like to think about it as, take for instance fractions. So let's say you have 3 over 4 plus, we could do 2 over 4. And we know that when we're adding fractions, if we have the same denominator, the denominator stays the same. We could add the numerators. 3 plus 2 is 5. So that's the same kind of idea with radicals. They both are the square root of 18. So that square root of 18 stays the same, and then we can simply add the numbers in front. So we have negative 3 plus 2, which is going to give us a negative 1. Now we have to simplify the square root of 18. So in our perfects list, so you have the square root of 4, the square root of 9, the square root of 16, and that's 2, 3, 4. This perfect list is really what we're going to focus on because if they're on this perfect squares list, then that's what we're going to use to simplify the square root of 18. So I know that 9 times 2 is 18, and 9 is on our perfect list. Remember, when we're simplifying radicals, we can only use the numbers on the perfect list here. So the square root of 9, that is 3, and 3 times negative 1 is going to give us a negative 3 root 2, and that is our final answer. Okay, let's take a look at example number 2. Make sure you pause this video and write this problem down before you get started. All right, awesome. So you recognize that both of the radicals are both the square root of 27. So I know that I can subtract, which is the operation that's being asked here. I know I can subtract these two radicals because they are both the square root of 27. So now I can take a look at the numbers out in front, and I have 2 minus 3, which, hey, gives us another negative 1. Now you need to look at 27 and say, can I simplify? Is there a perfect square that is in 27? And it is, because 9 times 3 is 27. So we can take the square root of 9, and the square root of 9 is 3. Remember, we multiply the number out in front, so it's 3 times negative 1, negative 3. Root 3 is left in the radical, and we are done. Okay, so let's take it up a notch. What happens when both of the numbers inside of the radical are not the same? Well, we got to make them the same if we can, if it's possible. So let's take a look at 45. Because 5, we cannot break down 5 anymore. 5 is, if we write down the perfect squares list for 9, 16, 25 even, the square root of 5, there are no new numbers, no two numbers that multiply to get 4 times 1 is just 4. So none of these would multiply to get to 5, so you know you're done. But for 45, we can break 45 down to, oh, that's a weird, 9 times 5. And that's the perfect that is inside of that 45 is that square root of 9. So now we can take the square root of 9. Square root of 9 is 3. And now there is a negative out front, which is really like there's a negative 1, and you can multiply these two, so that'd be negative 3 root 5. And we did not simplify the first one, so I'm just going to bring it down. This is negative 3 root 5. And now we can subtract those two fractions. So I owe you 3 root 5, and then I owe you another 3 root 5, and so really negative 3 plus a negative 3 is a negative 6 root 5, and you are done. Okay, let's try another one of those. Now, if you're feeling really confident, I highly recommend pausing this video, completely pausing it, trying this out on your own, press play, and see how you do. If you're not there yet, no worries. Let's continue to move forward. I'm going to take a look at both of these radicals, and I notice this one is the square root of 2, and I cannot simplify the square root of 2 anymore, but I can 18. So I'm going to break 18 down to 9 times 2. And the square root of 9 is 3, and 3 is going to multiply this negative 2, or subtract 2, same thing. So 3 times a negative 2 is a negative 6 root 2. And I'm going to bring this one down. This one is 3 root 2. And since they are both root 2's, I can now subtract them. So 3 minus 6, that's going to give us a negative 3 root 2. Okay, so we have 2 more left. These 2 are the most difficult. Let's take a look. Why? Well, both of these can be broken down. There are perfect squares inside of a 54 and a 24, and so we need to break them down and locate the perfect squares. So I'm going to break both of these down, and I'm going to draw a radical like this, which is what I encourage you to do as well. Now I want you to think of all the numbers on the perfect squares list, and you have 54. So 54 is 9 times 6. And 9 is on our perfect squares list, so 9 times 6. And then for 24, 24 is just 6 times 4. All right, so from there, the square root of 9, that is 3. 3 times negative 2 is negative 6 root 6. Now the square root of 4 is 2. 2 times negative 3 is another negative 6 root 6. That's cool. And so both of them are the square root of 6, so I can say a negative 6 plus a negative 6 is a negative 12 root 6, and we are done. Now, if that was a little bit too fast, make sure that you have the ability, well, that you know you have the ability just to rewind it, and that's okay, right? Rewind me, pause me, look at it over, slow my speed down. That's pretty cool about these videos. You have the ability to do that. All right, last problem. Let's go ahead and take a look at it. All right, I really do want you to try this one on your own. I believe in you. I know you got this. Go ahead and have your perfect squares list on the side. So you're either looking for a 4, a 9, a 16, a 25, a 36. Well, not 36 because it doesn't go that high, right? 27's our highest. All right, so go ahead and pause. Okay, let's see how you did. So hopefully you broke 12 down to 4 times 3. Now it's really common that I see students, they'll break down 12 to 6 times 2. I'm not arguing with you. 6 times 2 is 12, but 6 and 2 is not on this perfects list. So we can't take the square root of square root of 2, not perfect. Square root of 6, not perfect. So you need to have one of those perfects to come out. All right, so the square root of 4 is 2. There's like a negative 1 there, so 2 times negative 1 is negative 2 root 3. And then let's go ahead and break down 27. 27 is 9 times 3. And so we have the square root of 9 is 3. 3 times 3 is 9. Square root's 3. And they're both the square root of 3, so I can add them together. And I have a negative 2 plus 9. That's going to give us a positive 7, and we are done. All right, I hope that you guys enjoyed today's lesson, and I will see you next time. Bye.